Dear students, I am going to discuss Amdahls Law, which comes under first module of the course CS Computer System Architectures. So, first we are going to discuss what is Amdahls Law. It is actually a law that is put forward by the scientist named Jean Amdahl. He is a computer architect from IBM and the Amdahls Corporation. So what he does is that he has used this formula to find the maximum improvement possible by improving a particular part of the machine. So if you have a machine, if you want to improve some part of the machines by increasing the performance of any one part of your machine. So how your performance is affecting this improvement? That is actually put forward by the Amdahl. So this idea he put forward actually for the parallel computing. In parallel computing, Amdahl's law is mainly used to predict the theoretical maximum speedup for program processing using multiple processors. So multiple in the case of parallel processing, multiple processors will be there, and this multiple processors will be performing all of the executions at the same time using the multiple instructions. And in this case, how we can achieve or how we can gain the maximum speedup by using this particular law in the parallel programming way. That is actually Amdahl's law. The performance gain can be obtained by improving some portions of a computer. That is, if you have a machine, different number of components will be there. If you are improving some part of that particular machine, so what is the improvement that you will be getting, or what is the performance that you can be obtained by improving some part of the computer? Similarly, if you are taking the parallel environment, you will be having different processors. So if you are taking one of the processor and if you are improving the performance of that processor, then what is the total improvement that you are obtaining? That is actually Amdahl's law. So Amdahl's law states that the performance improvement to be gained from using some faster mode of execution is limited by the fraction of time the faster mode can be used. So this is the basic statement of the Amdahl's law. It means that suppose if you are taking the memory of your machine and if you taking the consideration, the memory will be improved for only 2 seconds. So that the amount of fraction of time that the improvement that you are using is also taking consideration for this final improvement. So the time that you are taking or the time that you are allowed to improve the particular part is also affecting the faster mode or the entire performance improvement of your machine. So the Amdahl's law defined the speed gained using a particular machine related to the improvement of the system's performance with the part that didn't perform well. So if you have a machine, you have to consider all the parts of the machine, and if some part of the machine is not performing well, you can improve it. So that will lead to result in the overall improvement of the system performance. That is actually Amdahl's law. So here there is two equations are given to calculate the speed up. One equation is speed up is equal to performance of the entire task using the enhancement when possible divided by performance for entire task without using the enhancement. So this equation takes the ratio between doing the enhancement and without using the enhancement. With using the enhancement and without using the enhancement. So the equation is performance for entire task using the enhancement when possible divided by performance for entire task without using the enhancement. Also, the speed up can be represented using the equation with respect to the time. Actually, the execution time is inversely proportional to the performance. So instead of this performance, you can use the execution time. So this will come like this: execution time for entire task without using the enhancement divided by execution time for entire task using the enhancement when possible, because the performance is reciprocal of the execution time. So the speed up is also depending on two other factors. First one is fraction enhanced, next one is speed up enhanced. So first we are going to discuss about what is fraction enhanced. The fraction enhanced, it is a fraction of time in the original machine that can be converted to take the advantages of enhancement. That means how much time taking the advantages of enhancement, that is fraction enhancement. So the value, it will be always less than or equal to 1. Next factor is our speed up enhanced. It is the improvement gained by enhanced execution mode. That is how much faster the machine or the processor improved due to the particular enhancement that they gained. That is actually the speed up enhanced. It is actually a value. It is always greater than 1. So this is how much faster the task would run if the enhanced mode were used for the entire program. That is speed up enhanced. So using this two fraction enhanced and the speed up enhanced, how we can calculate the execution time as well as the speed up. So the solution is the execution time using the original machine with the enhanced mode will be the time spent using the unenhanced portion of the machine plus the time spent using the enhancement. So the execution time using the original machine with the enhancement will be the sum of machine plus the portion of unenhanced portion of machine plus the time spent using the enhancement. So this is the two equations are given for the execution time and the overall speed up. So the execution time mu is equal to execution time mod into 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced. So the new execution time is depending on the old execution time into 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced. So next equation is speed up overall. This equation is very important equation. The questions related to this part is already asked in the university exams. So this equation is very important. Then the equation for the overall speed up is that execution time old divided by execution time new, which is equal to 1 by 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced. So we have already discussed how to calculate the execution time old divided by execution time new. The execution time old is the execution time without enhancement, and the execution time new is the execution time with enhancement. And if you are substituting the execution time here, then you will be getting the final equation. So this is the final equation that is used for evaluating the speed up of the machine using Amdahl's law. So what is the equation? 1 by 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced. You must remember this equation, and you have to note this equation. Next we are going to discuss a question from Amdahl's law. Our question is, suppose that we are considering an enhancement to the processor of a server system used for web serving. The new CPU is 10 times faster on computation in the web serving application than the original processor. Assuming that the original CPU is busy with the computation 40% of the time and is waiting for input output 60% of the time. What is the overall speed up gained by incorporating the enhancement? So this is our question. What we are identified, what we want to identify, that is overall speed up. We already know the overall speed up equation. What is the equation? 1 by 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced. So we want to identify the two terms. What is fraction enhanced? What is speed up enhanced? In our question we had given the new CPU is 10 times faster on the computation. It is a clue, and also assuming that the original CPU is busy with the computation of 40% of time. This is another clue for the two terms. So the solution is fraction enhanced is equal to 0.4, which is this value. The original CPU is busy with the computation of 40% of time. That means that 40% of time the machine is busy. So that is actually the fraction enhanced. Then next one is our speed up enhanced. So the speed up enhanced is CPU is 10 times faster on the computation. That means it is speed up enhanced is 10 times. So 10. The speed up enhanced is 10. Then the speed up overall is equal to 1 by this equation. Put into this equation. 1 by 1 minus fraction enhanced. 1 minus 0.4, which is equal to 0.6, plus fraction enhanced divided by speed up enhanced. We will get it into 1. The result is, so the final result is 1.56. So that is the final answer. Then I hope you all understood this problem. So once again I will tell you what is fraction enhanced. That means the fraction enhanced means the amount of enhancement that is attained. In our question, which is 40%, because the processor is busy in that time. The remaining 60% of the time it is waiting for the input output. So it is not an enhancement. So the 40% time is busy. So that is the fraction enhanced. And the speed up enhanced is 10 times faster. So we can compute the overall speed up using this particular equation. speed up overall is equal to 1 by 1 minus fraction enhanced plus fraction enhanced divided by speed up enhanced, and we will get in the final result. So today we are discussed about Amdahl's law and its problem. Hope you all understood this topic. Thank you.